mysterious technology interferences at Earth's poles has been investigated, where are devices using radio or satellite connections malfunctioning above the North and South poles. And this is the image from NASA. NASA wants to launch 3 missions to investigate the northern polar cusp, a funnel in space that may give a clue towards explaining the strange phenomenon. The 3 missions are all part of the Grand Challenge Initiative, CUSP, a series of 9 sounding rocket missions exploring the polar cusp. Each second, 1.5 million tons of solar material shoots off the sun and out into space, traveling at hundreds of miles per second. Known as the solar wind, this incessant stream of plasma or electrified gas has pelted Earth for more than 4 billion years. Thanks to our planet's magnetic field, it's mostly deflected away, but head far enough north and you'll find the exception. Most of Earth is shielded from the solar wind, said Mark Conde, space physicist at University of Alaska in Fairbanks. But right near the poles, in the midday sector, our magnetic field becomes a funnel where the solar wind can get all the way down to the atmosphere. Our polar cusps are something else responsible. These funnels, known as the polar cusps, can cause some trouble. The influx of solar wind disturbs the atmosphere, disrupting satellites and radio and GPS signals. The northern polar cusp also has a patch of a dense atmosphere, and this could be a real problem for our spacecraft. A little extra mass 200 times up might seem like no big deal, said Conde, the principal investigator for the CUSP Regional Experiment 2, or CREX-2 mission, but a pressure change associated with this increased mass density, if it occurred at ground level, would cause a continuous hurricane stronger than anything seen in meteorological records. This additional mass creates problems for spacecraft flying through it, like the many satellites that follow the polar orbit. Passing through a dense patch can shake up their trajectories, making close encounters with other spacecraft or orbital debris riskier than they would otherwise be. A small change in a few hundred meters can make a difference between having to do an evasive maneuver or not, Conde said. Turbulence is one of the really hard remaining questions in classical physics. We don't really know what it is because we have no direct measurements yet, said Norwegian space physicist Lauren Moen, who leads CUSP Irregularities 5, intended to measure turbulence and distinguish it from electric waves. Moen likens the turbulence to the swinging eddies that form when a river rushes through rocks, and when the atmosphere grows turbulent, GPS and communication signals pass through it can become garbled, sending unreliable signals to the planes and ships that depend on them, of course. And this is on Message to Eagle by Eddie Gonzalez. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.